There. Now the mic is on. Let's see. Is it actually working? There. Okay, good. We can't make an array of type T, but what we can do instead is make an array of objects, which could be anything, and then immediately after it's made, we just say, but they're type T. And that's what the casting is doing there, that thing in the parentheses right there. All right? And if you're saying, why? That's annoying. You're right. It kind of is. There's a reason for it, but for now, annoyingly, it's kind of the magic code you have to write to make an array with generic types underlying. All right? So, oh, and then this extra annotation here, you don't need to include it. But if you don't, you'll get a warning saying like, oh, unchecked cast. It doesn't matter, it's just a warning. When you say suppress that warning, you're just telling IntelliJ and the compiler like, no, I know, this was intentional. All right, so there's an example view of what an array stack would look like if we created a stack, reference variable s, of integers, with new array stack 5. And we specified 5, which means that's the default capacity because that's just what we wrote. So to start, we've got this reference variable s. What is the type of reference variable? What's the type of that reference variable?
Integer?
Nope. Nope. It's not really a trick question. You can just look at the line of code right there. It's a stack. But it's weird though, because stack wasn't like a class. Stack was an interface. But that's fine, and that's by design. I just have a reference variable for some stack. What's on the right-hand side, the actual instance, the actual type of the thing being created, is array stack. Why? Well, it says right there, array stack. As far as Java is concerned, when I write something as like stack s, stack integer s, all that matters is that the thing on the right-hand side implements a stack. That's all that matters. An array stack does. But we can implement a stack with some other class as well, which we will see shortly in the course. But there's the idea. We create a new array stack, size 5. So what do we have? Well, we've got a reference variable s that references some collection of information. It's got a basic integer top that references the next available spot in the array, and also happens to correspond to the number of elements in the array, so it's doing double duty. And we also have a reference variable called stack that is a reference to an array of size 5, of capacity 5, maybe I should say, in this example. So let's write push. This is going to look really familiar to what you did in assignment 1, what we did in lecture with the contact list, and what we did in lab with the courses. It's just appending to the end. That's all it is. That's what we're doing here. That's how our array stack is defined. So ignoring the whole expand capacity thing for a moment, all we say is go to the stack, index it at index top, which is always the next empty spot, right? It's the next empty seat. If you're a line of people in the stack and you're the bottom of the stack and you're the top of the stack, top references that next to you, that next empty seat. It's not the thing on the top, it's the next empty seat by the design of it. We could implement it where it was the thing at the top, but we're not because we also get that whole double duty as size, which is nice. So you go to index top, you put the element at that index, and then you increment top because as soon as we added something, well, it now sits in that seat. It now takes up that index in the array, so we have to update the size. We added something. We update the size. We update top. And then with something like this that's modifying, we just have it. This push here returns a Boolean, and it's always going to return true by design of how it's done. We could have designed it where once it hits capacity, it just doesn't add anymore, it'll return false. But in our implementation, we can never actually run out of room in the array because when we do, we just make a new array, copy everything over, and carry on as if everything's normal. Right? And that's what's going on in expand capacity. So if we look at expand capacity, aside from the whole funny making an array of objects and casting it to T, that's the same expand capacity you've seen on Wednesday that we talked about already in this in the contact list, in the course list, and the country catalog, right? It's the same thing. Create a new array, twice the size. Then you've got a for loop where you copy all of the elements over from the original stack to the new stack. But remember, we're not really copying the elements, we're copying the references to the elements, but that's fine. And then when we're done, the reference variable stack, we just update to reference the new one. So the old array just kind of disappears. It gets collected by the garbage collector. That's all. Any questions about that? This is effectively the same add. This push is the same add we've seen all semester so far. We just called it push here. Okay. Oh, you'll also notice that it overrides push. This compiler annotation where it says override is not necessary, but it's kind of nice because it also tells you, well, this is actually like implementing, this is overriding the signature from the interface, right? So we're overriding that one. And it's funny because you can override already implemented methods, like we can override the toString. If you don't write a toString, you get a toString for free. It's got functionality. But this, we're not overriding an already implemented thing. We're overriding something that was defined in an interface. So that word has like two meanings. So yeah, there's our expand capacity, great. Override, yep, great. Pop and peek. It's going to be easier to do peek, so let's jump to peek. So what do we want to do if we try to peek from an empty stack? We've got a lot of options, but I like the idea of raising an exception, throwing an exception. If you're peeking of something that's like an empty stack, maybe you're using the stack wrong. Maybe you really meant to do it, and if you did, you just deal with the exception that gets thrown, fine. But that's kind of like a peculiar thing. When you peek, you expect to get a value back. If it's empty and you peek, you're not going to get a value back because that's not possible. So that's the exceptional situation. Sometimes it might be kind of hard to think like, well, how would I really know to do an exception there? The real answer is, well, you don't. That's a design decision. But here, it makes a lot of sense because, yeah, peek and pop, when you do it, they're supposed to return a value. But if it's empty, it can't return a value. So that is the exceptional situation. It will not behave the typical way. So that's the exceptional situation. So what do? Well, we return whatever's in the array stack at index top minus 1. Because remember, top is an empty spot. So you can't return that. That'll just return null. So you return top minus 1 because that's actually where that element is. That's on top. And then peek, well, that was peek, pardon me. And then pop, well, we do the same check for empty, right? And you'll notice I added a message there. Here the message just says empty stack, whatever. You don't really need to add a message, but it's a little handy. So if we try to peek and it's empty, and you'll see it's using the method isEmpty, which we haven't written yet, but we'll look at it in a moment. Otherwise, you get the element at top minus 1. You go to stack at index top minus 1 and you set it to null, which is technically really not necessary here, but it's always kind of good to do to clear out the information that's really not there anymore. The reason we don't, let me finish explaining, then I'll come back to it. We decrease top and then return what I call the return element. The reason we really don't need to set top minus 1 equals null is by decreasing top. That's saying like, well, remember top is the next open spot. So although there would be something still there if we never set it to null, the next thing pushed would immediately overwrite what was there before anyways. That said, it's always good to write, just because it's also correct. What do you think I suppose this is a little bit in the eye of the beholder, but to me, the code is clearer. This is better code than just kind of like counting on the fact like, well, it's rewritable effectively when we set it to that. When you really say like, no, you're null now, it's more informative code. It's very defensive code. You might also say, you could have decreased top before the lines 65 and or 64 and 65, you could have decreased top there, and then you wouldn't have had to have done top minus 1, top minus 1. Did anyone kind of think that? 2 people? Let me specify. If I decreased top before these 2 lines of code here, so if I did it up here, I wouldn't have had to say top minus 1, top minus 1. And you're right, you could totally do that. But to me, this code, you know, when you're writing code, it's not just about writing it, getting it correct, and moving on. It's about writing and going like, is this code well written? And to me, when I think of that question, I go like, you know, to me, when I think of the processes, I'm thinking of what I want to do in an order. And the order in my mind is, okay, get the thing, make it null. I'm pointing to you because you were the top in the last example. Well, you were top minus 1. I go, get the thing, set it to null, then decrease top, right? Because top is also size, so we remove something. So to me, that order made sense. If you wrote it in a different order in your assignment or something, I'd be like, yeah, fine, whatever, that's fine. But to me, it just makes a little bit more sense here. We also kind of saw in lab, I showed some people, maybe some people didn't see or they weren't noticing or it was the other lab, that you could actually write top minus minus in the indexing and it would also work. But I don't like that because that's 2 like statements in 1 line of code. I like my code to be very like da 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 da. Very clear, simple, easy to follow, easy to understand. Any questions at all about peek and pop? Remember, now's the time to ask. If you have a question, chances are there's a half a dozen other people in the room with the same question, so ask. I get bored talking at you. All right, so yeah, exceptional. There's this idea of the principle of least surprise. It's kind of what I was getting at where I'm like, well, if peek returns an element, typically, what would I return if it was empty? Let's say I didn't want to throw an exception. What should I return? It has to return something. The function must return something. The method must return something. So what should it return? A sentinel value? What would that be? Maybe that sentinel value is reasonable for how you're using the stack anyways. Like if it's a stack of integers and the sentinel value is -1, what if -1 was a valid thing that could have been on the stack? Suddenly, so it would be weird if I got back something. It would be surprising if I got back something that really wasn't there. That would be a surprise. Like, whoa, that wasn't there, and I just peeked and it gave me something? That's weird. The exception helps us conform to the principle of least surprise by like, oh, you're supposed to get a value back, and I did it. Oh, it was an exception, something funny. Yeah, okay, yeah. Size and is empty. Well, size, that's just top. Is empty, well, is size 0. That's all. Size is 0. And remember, you can return the result of that expression. Because the question size, that method called size, equals 0, that's an expression, that's a Boolean expression that will return a Boolean. Right? So size, that returns 0. Does 0 equal 0? Yeah, okay, it returns true. You might be thinking, okay, but you know, he just went on a big rant about making the code as clear and concise as possible. Maybe he should have, maybe he could have used another variable to be like, is empty calculation equals the result of this and then return that. You're right, we could, but this, in this particular example, an expression written like that is very typical. That's just how a programmer would write this method. So although maybe we could make it more clear by coding it a little bit different, people would argue, well, this is such a simple method, it should be pretty clear in and of itself. But if you think I can make it clearer for myself, by all means. All right, toString. Now, toString for a stack, we have a decision to make. Because where do we want the top of the stack? Like, think back to Python. If I print out a list, it kind of just shows you square bracket elements in a row, and then a close, right? And there's an order. And I could do something like that with the array stack. right? I could do, okay, start at index 0. But if I do, I'm printing out where the bottom of the stack is the first thing I see, right? Because index 0 of the array is the bottom of the stack. The top is the other end. So if I start at index 0, and then index 1, and just print all those things out, then I have the bottom of the stack at the beginning of my line of things, which is entirely fine. That is entirely doable. There's nothing wrong with that. So you would have, I'm seeing some people kind of squint their eyes like that didn't make sense. If I start at index, remember, the top of the stack is at index top minus 1. Index 0 is the first thing that was ever pushed on the stack and never removed. So if I start creating a string starting at the value at index 0 of the stack, that's the bottom of the stack. And then if I'm always like concatenating to it, I'm just building it up, right, as I go. So then the top will be over here, which is entirely fine. There's nothing wrong with doing it like that. But to me, I like it more where I want the top to be at this end. So really I want to build the string like in reverse. I want to start at like the top and then go to the end, right? That's really what I want to do. And that's what this code is doing. But it's doing it in kind of a fun way. There's a lot of ways I could go about doing it. To me, this was the easiest. I used a string builder. But the other string builders we used, we called like append, which means add to the end. This uses insert, where I can specify an index that I want to add it at. So I'm always saying, oh, at index 0, add this thing. Now at index 0, add this thing. So I'm always kind of like adding to the front of this string builder. That's what I'm doing. Append really is just calling insert at the last index all the time. In fact, it's probably actually written as a method like that, where it actually just calls another method. I'm kind of curious. Let's see if we can find that. If I call, no, I want builder append. Oh, that's not what I wanted at all. Append 2. What? Yeah, this doesn't look good. It's a little bit more complex than that, I suppose, so I sadly won't get a sense. Rats. It's a little more complex, unfortunately, than just calling the other method. I thought maybe I'd be able to call it, but I guess not. But that's fine. So there's the toString. Any questions about the toString? Yes.
Okay, so you have builder.insert 0, and then how come you have quotations with a comma in it?
Well, that's because what I want to do is, think about it. I want to have a comma between each element.
Okay.
And you're saying, but you're starting with the comma. That doesn't make any sense. But remember, I add a comma, and then I insert immediately in front of it the value I care about.
Oh, so you're inserting in front.
And then add another comma, then the value.
But then don't you just have a comma at the end?
Yeah, but I don't care. I'm fine with that. I could do a check where it's like, if it's the first one, don't include this comma. I could do that entirely fine. But for my purposes, that's fine.
Okay.
Equals and hash code. Okay, well, let's look at the equals. All right, are they literally the same thing? Is it not all, or the classes don't match? Okay, and then we use the arrays dot equals. I could do this by looping over all the elements just fine and doing the equals myself, but this built-in arrays dot equals will do it for me, because why not? And then our hash code, I hash the top, and then I loop over all the elements, and then I get each element's hash code, and add it to the result times 97, and then just go. Why? Because I think this is the one that IntelliJ auto-generated for me. That's why. But that right there is a fairly typical hash code for a collection. You could probably copy and paste this for a queue, which we'll learn later. I don't know, 2 arrays, okay. Like other methods in the class, the override onto, yeah, okay. Oh, this is just talking about the overrides overriding from different places. One was the overriding from the object class, the toString, the equals, the hash code. And the other override was overriding the signatures from the interface for the stack. Okay? All right, and that's it for a stack. That is a stack implementation. Raise your hand if you think a stack is a hell of a lot simpler to implement than a country catalog. I do. It certainly is. It absolutely is. A country catalog is actually quite a complex object. It's a very complicated and complex collection, that's for sure. So I threw you into the deep end. So the good news is we're actually getting simpler. The bad news is, I suppose, is I'm not actually going to ask you to build a stack, though, because I gave it to you. You're going to use the stack to solve fun problems, like solve a maze, for example. The next collection we'll learn about, the queue, is only a little bit more complex than, well, the linked implementation is only a little bit more complex than the stack, but still not too bad. But we work our way up to more and more complexity as we go. Any questions at all about stacks? Yes? Will they be on the midterm? All right, I'll be nice. Will stacks be on the midterm? No. The midterm will include, so I was telling everyone before, it can include anything up to and including the day before the midterm. It's not. It's going to include all of like the review content. Doing assignment 1 is great prep for the midterm. I wouldn't say it's sufficient prep. I wouldn't say, oh, if you just squeaked by and did assignment 1 and you got it working and you're therefore good to go on the midterm. No, I wouldn't say that. But, you know, that's the type of stuff that would be on the midterm.
So we're not going to just redo the entire assignment for you on the midterm?
Maybe.
Why would you do that? Why would you even
I would have to
say
be pretty psychotic to do that.
Why would you even suggest doing that?
Sorry. Okay, all right, I take it back.
Thank you.
I will not make you re-implement a country catalog on the midterm.
All right, thank you.
Yeah.
Would you hash maps on the midterm?
Will you need hash maps? I don't think so. I don't think so. And if I did, and right now you're worried about like syntax and how do I do it and what's the generic, I have to specify that type of thing would be very cruel for me to be like, no, you put the order of the generics wrong in your declaration of the reference variable. No. I'll be like, all right, it's a map, whatever. They know what they're doing. The way I write my tests, I try to make them, if you've heard me say this already, you've probably heard me say it a bunch already. I try to make my tests, if you know what you're doing, and I don't mean, you don't need to be an expert, but if you're following along, you're up to date, you're on top of it, you've been doing your assignments, you've been doing your labs, and you get it, the test should be easy peasy. I want you to get as close to 100 as possible. If you kind of show up to lecture, labs, whatever, you don't show up, and the assignment, maybe you got it working because you just kept changing the code till all the tests pass and you're happy because of that, I want you to get as close to 0 as possible on that midterm. Because the tests are designed to determine how much you understand. So I want to know how much do you understand. And if you don't understand anything, I want to know, do you understand nothing? And also when it comes to marking, what I want to mark is, do you understand what the question is trying to evaluate what you understand? So if I ask a question about how to do, like take, for example, last semester, there was a lot of linear searches, right? There was a linear search on the midterm and a linear search on the final, right? So when I asked you to do a linear search, what I was asking, the question was, do they understand linear searches in the edge cases? The important bits. What I don't care is, oh, they got their syntax wrong, the indents were out of place, they forgot their parentheses there. That, not important. What's important is the algorithm. So that's what I go for in the tests. I'm worried my test is too easy for this semester, but I don't know. Who knows?
Make it easier.
Make it easier? It's too late. It's already made. It's in a PDF. It's not changing.
Unit tests on the midterm, like I know you might have them, say if you're like write a function that passes these unit tests, but you're not going to be like, write a unit test for this.
No. No. All right.
Think about it.
Think about it?
Don't think
Oh,
about it.
don't think about it.
Yeah.
Well, now it's a PDF. I can't change it.
Yeah, good.
Otherwise, I have to change it and then regenerate the PDF?
Oh,
Forget it.
oh,
Not happening.
too much work.
I know. You're right. You know. ChatGPT? Honestly, I thought about it. I asked, like, what is a good question for a second semester, blah, blah, blah. And it gave pretty good suggestions.
Pretty good.
Yeah.
There you go.
All right. All right, here's some plain code that you could use for the stack. Obviously, you can download the stack interface right here, the array stack implementation, and the array stack tests. But you can also download this, what I call the plain code. And the plain code, this is literally it. All it is some main method that creates a stack, specifically an array stack with a capacity of 5. Why 5? Just because I wanted to kind of check if expand capacity was working. I push 5 things, I get the size, check if it's empty, you know that should say 5, it should say false. Print it out. Add a couple more things, make sure everything kind of worked correctly. So this is just some plain code, nothing particularly interesting. That's all. Speaking of unit tests, let's go back to unit tests. So, for those of you that were in lab yesterday, raise your hand if you were in lab yesterday. Raise your hand if you started writing unit tests for the course list. Raise your hand if you're like, this is a pain in the ass. Raise your hand if you're like, this is a giant pain in the ass. Yes, you're right. It is. And there is a core reason why it's a pain in the ass. Let me put it this way. Relative to testing on a scale from 1 to 10, how much easier, 10 being absolutely 1,000,000,000% easier, 0 being, no, it was similarly difficult. How much easier was it to test the course class? Someone yell out their number, 0 to 10, 1 to 10. Say 10. 10. It was it was so much easier. Right? Testing the course class was trivial. All right, you create it. Get its name. Did it give me its name? Get its code. Did it give its code? It was trivial, right? The problem with testing collections is, well, look, we've been emphasizing immutability. Don't make your data have the ability to change states. Don't do it. Once it's created, leave it alone. It only can ever have its state that it existed when it was created. Don't modify anything in there. Leave it alone. If you really want to modify it, you can't, but you can make a copy with the new information. But the point is, the original was left alone. It never changed. Another thing was side effects. This goes back to 161. Side effects can be the root cause of a lot of issues. The idea of a side effect is, so there's a pure function. A pure function is, I have a function, it takes some parameters, some arguments, some input, and it gives me some output, and that's it, and it leaves everything else alone. I give it 2 numbers, it gives me back the sum of the 2. Great. It didn't modify anything anywhere else inside the code. Side effects are when your functions modify things somewhere else in the code. And we like our functions to be we want our functionality in our code to be as independent as possible. I want to be able to use this function. And, well, that function requires you a dependency on this other function. It's like, okay, that's not necessarily a bad thing, but is it possible to write these 2 things such that they don't? Imagine I had a function call that has another function call in it. There's nothing wrong with that. But I might ask the question, is it possible to not actually call the other function in that other one? Is it possible for me to ask this function to do its thing, give me the result back, and then based on the result, I give it to the other function, right? Could I do it like that, or they really need to be tied and coupled, where one calls another one? The expand capacity is a very coupled function. It's required there, right? So that's what we strive for. But collections typically, traditionally, the way they're implemented, kind of is the antithesis to these ideas. Okay, we don't want mutability, right? We hate mutability. Well, I got bad news. The whole point of a collection is that you can keep modifying the contents of that collection. That's the whole point. append, remove, append, remove, append, remove, push, push, pop, pop. The other thing is, those pushes and pops, they are all side effect. Here, function, take this value. Great, thank you. I'm going to return a Boolean, but before I do that, I'm going to go modify the contents of some array somewhere in my program. Right? So we've got a heck of a lot of side effects. And on top of it, all of these methods inside these classes, these collections, are so inextricably interconnected, it becomes very hard to test. How on earth could I test an add? How can I test push without making use of other functions, other methods in that class? I can't. Push. Okay, did the thing get added? I need to call, like, peek, right? To check if it's there. So in order to check push, I need pop or peek. In order to check pop, I need push. They're very connected. And consider for a moment the stack. What should happen to my stack when I pop from the stack? What should I do? Well, the answer to that is it really depends. Is the stack empty? If it's empty, what should it do? Someone yell.
Throw error.
Raise the exception. Throw the exception. Exactly. What happens if there's one thing in it? What should it do? This really shouldn't be a trick question.
Probably just like pop that.
Yeah, just return the thing and make sure it's not in there anymore, I guess, right? Like it actually got removed. And then peek would be the same. Did it return the correct value, but did it not remove anything? Like the state shouldn't change with peek, right? In fact, it's funny, with pop, when I remove, the state of my stack should be equivalent to an empty stack. If I have one element in that stack, if I pop from it, it should be equal to an empty stack. But if I have several things in it and I pop from it once, it's not going to be equal to an empty stack, it's just going to be different. So the behavior of these methods really depend on the current state of the stack. And this is part of what makes it such a pain in the ass to test collections. And the whole point of yesterday's lab, so those of you that have lab on Monday, you're ahead of the curve. You're going to have a one-up on this because you might be able to take what we're going to learn today. Is testing collections is a giant pain in the ass. But the good news is, it's not great news, but the good news is we have strategies. We have coping mechanisms for testing these collections. So I'm not just going to start yelling these strategies at you. I'm going to work you through an example of how I might go about writing tests and motivate the strategies as we go. But step one, I'm going to test one of the states first. I'm going to start with empty. Let's assume the stack is empty, and let's write all of the tests for all of the methods, assuming the class is empty, the stack is empty. That's where we're going to start, okay? So, we start, it's empty, let's write these tests. All right, what do I have here? All right, yeah. So, what happens if I push on an empty stack? Well, push empty stack should return true. That's what should happen. So my test says create an array stack, and then push some arbitrary number on it, and assert true that after that call it returned true. That's what that's doing there, right? I've nested the method call inside the method assert true as the argument, but right? So when I say class under test.push 11, that should return true. So if the result of that call is true, assert true will be happy, right? First, note that it's called class under test. This is very typical. It's very common to call the reference variable to the thing that you're testing class under test, because it's the class we're testing, right? Push empty. Well, that should also result in a new top, right? It modifies the state of the stack. So when I push, I should be able to peek and get back 11, right? There's no mystery there. It's what I should see. When I pop on an empty stack, it should throw a no such element exception. And you'll notice that assertions, these JUnit checks for exceptions are a little funny. Because, and there's a reason for it. Really what you're passing to assert throws is the thing you're looking for, the no such element exception dot class. That's the name of the class. The no such element exception class. But the right-hand side with these like parentheses and an arrow, that's like a lambda. It's kind of like an ad hoc function that we're writing. And the reason we're doing that, actually I'm not 100% sure if this is true, but this is always what I had assumed, is if I call class under test.pop, I'm expecting it to return something, right? But it's not the return value that I'm testing. It's like an exception is like a side effect, right? It's a side effect. So I had to kind of create this like, call this function with this lambda, like I'm redefining a new function, this really quick little lambda expression that has the side effect I'm looking for. Everything I just said, just ignore it. Forget it. It didn't matter. This is the magic code you need for testing exceptions. Assert throws, the name of the exception dot class, and then you have these like parentheses, arrow, and then what you want to call it. Okay? Peek empty should do the exact same thing, just replace pop with peek. Is empty should return true. Size should return 0. ToString should return an empty string. Great. That's it. Those are my empty tests. Do you notice anything about these tests? Any observation at all? Let's talk about it. They're simple. We like that. We like them to be simple. It's good. Anything anyone's noticed about them? Any thoughts, comments, concerns? You'll notice every single one of these tests start with the exact same line of code. Array stack, class under test, new array stack. Every single one of them starts like that, right? There's nothing wrong with that, but that's kind of, redundant. We don't like redundant code. So we actually have a nice little tool we can use. We can create this special little method that we annotate with an at before each that says, okay, it's basically like tacking on this line of code before each of the tests. And what I've done is I've created actually a field for the class, for the test class, the array stack test class. I made a field called class under test. And then in my before each that I've just called create stack, I just create the instance of it. Now, I don't need to include that line of code, right? I don't need this line of code before every test. For example, the push empty returns true, I just go right to it, right? So the test becomes more about what it's actually testing, which is kind of nice, right? We didn't need the setup code in the test itself. So that's a nice little way to kind of like take out that common setup code. Any questions about yes?
What specifies that it's going to happen before each line?
The fact that it says at before each.
Oh, that actually is an action?
Yes, so that's an annotation for JUnit, the testing environment.
Oh,
so, yeah, good catch, but that's really what it is. It just goes, oh, okay, this is going to get called. There's actually a bunch of other little annotations you can add. I wouldn't be surprised if there's like a after each. I really don't know, but maybe there is. There's going to be a lot. So there's an easy way to do it. Get rid of that common setup code. Right, so now let's start writing tests for what happens when we have one element in our stack. How should it behave? I'm also including something called pre-state now. I'm making another field for the class called pre-state. And pre-state's actually only going to get used in one of the tests for now. But this is also common to have another test class field for keeping, where you always have like a copy, an equivalent version of the class under test that you can use for checking something. And you'll see an example of it used below where I do peak. When I called peak on class under test, after it, it's still equivalent to pre-state, meaning peak didn't modify anything. So it's just common to actually also always have a backup copy type thing for comparisons for your tests. So that's why you'll notice this pre-state thing. And all I did is just, it's always going to follow along whatever happens to class under test. Okay? So I've excluded the empty tests, okay? So pretend they're there, I just removed them for brevity here. Let's look what happens. Okay, so push. All right, class under test, push, pre-state push, whatever. That's just, setting up. And then assert true, class under test. If I push 11, it better give me back true. If I push, it should update what the top is, right? So when I peak, after pushing 11, the top better be 11, not 10, right? If it's working properly. Pop, well, that should return the value at the top of the stack, which is 10. Ooh, here's a mistake. I forgot to include pre-state here. Someone can go fix that. Oh, wait, no, that's going to be in the source code. Well, either way, someone can go fix that. Pop singleton. So after I pop, the class under test better be equivalent to a new empty stack, right? There was one thing on the stack, I pop it, it's now empty. Well, it better be equal to an empty stack then, right? No mystery here. Peak returns top, peak unchanged. That's where I'm using pre-state. I call peak. Class under test and pre-state better be equal, meaning peak never modified. It never removed anything, it never added anything, it never did anything weird, it had no side effect. It left it alone. That's good, that's what we want. Is empty, better return false. Size is going to return 1, I'm going to guess. Look at that, I'm right. Return 1. And toString returns the string I'm looking for. Great. What do you notice about this code? What do you notice about these tests? Any observations you can make? In fact, I made an error with all my setup code. What were you going to say?
You're pushing 10 on the class under test and pre-state every
Yeah. So I just made an argument moments ago about removing that setup code and putting it into that common setup before each function, right? Or method. But now here I'm doing that again. I've got the exact same identical setup code. In fact, interestingly enough, I even made a mistake. I actually forgot to update pre-state for this one, even though it really didn't matter for the test, but for consistency's sake, probably should have had the pre-state.push10 in this test as well. And if I had something like common setup code, that mistake couldn't happen, actually, because I only have to write it once. But here, I had to do it a bunch of times and I missed one. Rats. All the more reason to avoid redundant code. I swear this wasn't intentional. But we've got a problem. We can't throw this into the before each, right? Because the initial before each that we just looked at created an empty stack, and the empty stack tests required that the stack was empty. So I can't just go start pushing things in that before each, because then they won't be valid for the empty stack tests. Right? So what do? Well, here's what we do. There's the trick, is we create nested tests. We create classes inside the classes for specific states that we're testing. Hang in here with me. So I've got my before each, create a stack. I now have a nested class called when_new_empty that doesn't do anything to the stack that was created. It's got all those tests, right? I've excluded most of them just for brevity. If you download the tests, you'll see them all. But then inside this when_new_empty class, I have another nested test class called when_singleton. And within this one is going to be all the tests for when there's only one element. We use the word singleton to mean like, the case where there's only one thing in there. But because of that, we can have another before each. But the before each inside this nested class only applies to the methods inside that nested class, and any other subsequent nested class if you have them. So, this, what I call push, this is also, my goodness, I've got bugs all over the place here. Push empty, this should say singleton. My goodness, I've got bugs in or errors. Add singleton. In reality, push empty, pop singleton returns top, let's say. Okay? When I do that, it actually called the two before eaches. It does the first one from outside, which is, create them. And then the one inside the nested class that pushes one element on it. So now I don't need all that setup code inside anymore. It's nice and easy, I like it, yay. So I've eliminated the need for that setup code by taking it out to a before each, but because that before each is in a nested class, it only applies to those inside that nested class. So all of the empty tests get left alone. The other added benefit of these nested classes is it makes it so much easier to separate the parts that you're testing under different states. Here are all my tests for when it's empty. Here's all my tests for when there's one element in this nested class. And here's all my tests for when there's several in that nested class. So it's a heck of a lot easier. So it's clear too, I suppose that's my point. And then lastly, if we want to write tests for the more general case, where there's just some arbitrary number of elements, not just one. It's not empty, it's not just one, but there's some arbitrary number of them, make another nested class. So we've got our new empty, our when singleton, and then inside that I have a when many. You'll also notice this extra annotation here. It's the magic code, you need it. But all I'm doing is pushing 20, 30, 40. But this will take place after the initial before each, which created them, and the singleton before each, which added the number 10. So all of these stacks will have the numbers 40, 30, 20, 10. So even though this one doesn't explicitly say push 10, it would have been pushed from the previous before each. And then it's the same. That's it. This layout and this strategy is by no means the correct way. There's no Java documentation that says this is the way to do it. But this is a damn good strategy for testing collections as they get quite complicated and hard to test. All right, see you later.